Faraday's laws of electrolysis. Now, when we talk about the laws of electrolysis as put forward by Faraday, also known as Michael Faraday, he puts forward two concrete laws which points to the fact that the quantity or amount of an element discharged during electrolysis depends on three factors. What are these factors? First is the magnitude of the steady current that is being supplied. Second is the amount of time for this steady current to pass. And lastly is the charge on the ion of the element. The charge on the ion of the element. So these are the factors that Michael Faraday considered in his laws of electrolysis, the two main laws of electrolysis. So let us put forward the first law and consider what the first law of Faraday is talking about. So Faraday's first law states that the mass of a substance liberated or discharged or deposited during electrolysis is directly proportional to the quantity of electricity that is passing through it. So during electrolysis, the mass of the substance that will be discharged is directly proportional to the quantity of electricity that has passed. That is just what Faraday's first law is talking about. So if we are to express that mathematically, we will say that quantity of electricity is directly proportional to the mass of the element discharged, whether it is a metal or a non-metal. So the mass of the element that is being discharged is directly proportional to the quantity of electricity that has passed within that time frame. And when we talk about quantity of electricity, of course, like I said, within the time frame, quantity will have to do with the current that has flowed multiplied by time. So Q is equal to IT from our physics knowledge. So we can therefore say that mass is directly proportional to IT. And if we're to remove the sign of proportionality, then that gives us mass is equal to ZIT. Sometimes the Z is represented with the letter E. So you may see M equals EIT, where these parameters have their meanings as we can see. Mass is for M, I is current, T is time, and Z is the constant of proportionality. Like as I said before, sometimes Z may be written as E. It is still representing the constant of proportionality. We shall get to see that it is called electrochemical equivalence. So we shall get to talk about that, or you'll be learning about that even more in your physics. So let's proceed to looking at what and how to apply the first law of Faraday in some calculations. So our first example we shall be talking about is as the question goes, it said what is the quantity of electricity that is produced by the passage of 2 amperes of electricity, of electric current, just for 5 minutes. So what is the quantity of electricity that will be produced if a quantity of 2 amperes, if 2 amperes of current is meant to flow for just 5 minutes, what will be the quantity of electricity that will be produced for that 5 minutes? So to solve such kind of question, it is first to bring out what has been given to us, bring out our variables. Our current is 2 amperes, time is 5 minutes, so the current flowed for just 5 minutes, and we are asked to calculate the quantity. So from what we have just seen initially, that Q is always equal to IT, then we can say Q is equal to 2, which is the current, times time. Time is usually in seconds, though if we are told to leave our time in minutes or hours, that isn't a problem. But otherwise we convert to seconds, so it because current will always flow per seconds, of course. So Q equals IT, it means we have 2 times 5 times 60, and 5 times 60 gives us 300, and that will give us 600 coulombs. So the quantity of electricity that has passed in 5 minutes is 600 coulombs, and this is a very good example